Hello. Today, we're taking a journey from the edge of our world to the birthplace of stars. That green aurora you see, it's actually a planetary shield in action. Solar particles smashing into oxygen atoms 60 to 400 miles up, exciting them to glow at exactly 557 nanometers. But let's hit the accelerator. To see Earth shrink this fast, we'd need to be moving at a significant fraction of the speed of light, 186,000 miles per second. As we pull away, notice how the atmosphere vanishes. Those faint city lights on the dark side are the only evidence of humanity left in the void. We are now in the deep water of the cosmos. That band of light is the Milky Way, viewed edge-on from our spot in the Orion Arm. It spans 100,000 light years, but it's not empty space. It's filled with invisible interstellar dust that blocks the light of billions of stars behind it. Let's compress reality. In our neighborhood, stars are 4 to 5 light years apart. But at this simulated warp speed, relativistic aberration turns them into streaks. We are tunneling through the galaxy, closing the distance to that reddish structure growing in the center of your screen. We've arrived at an emission nebula. It looks like thick smoke, but don't be fooled. This gas is a better vacuum than anything we can create on Earth. That deep red glow, it's simple atomic physics. Ionized hydrogen fluorescing under the intense ultraviolet bombardment from nearby stars. We're going inside. These towering structures are freezing, hovering near absolute zero. See those dark, opaque knots? Those are Bach globules, dense cocoons of silicate dust and ice, where gravity is finally winning the war against pressure, collapsing gas to form new stars in the dark. And there's the prize. The color shifts to magenta here because of massive O-type stars embedded in the cloud. These giants are 90 times the mass of the Sun, blasting out energy that strips electrons from atoms. They live fast and die young, but for now, they light up the nursery. We are now drifting through the interstellar medium itself. These billowy shapes aren't random. They're shock waves carved by stellar winds. It's a beautiful, violent cycle. The stars create the elements, blow them out into these clouds, and eventually, we are made of this exact star stuff. We are now navigating the physical terrain of the nebula itself. It looks like thick smoke, but don't be fooled. These clouds span over 100 light years, yet the density here is incredibly low, often less than 100 particles per cubic inch. That's billions of times less dense than Earth's atmosphere. And that stunning pink glow, that's fluorescence. High-energy ultraviolet radiation from massive stars, is stripping electrons from hydrogen atoms, and when they recombine, they emit this specific frequency of red light. Look at how the gas is clearing out here. This isn't random. It's a violent excavation. Those bright beacons are massive O-type stars, burning at surface temperatures exceeding 50,000 degrees Fahrenheit, 27,700 Celsius. They unleash stellar winds, traveling at over 4 million miles per hour, 6.4 million kilometers per hour. It's pure photon momentum, radiation pressure, literally pushing the surrounding matter away and carving out these cavernous voids in the nebula. Now the environment turns chaotic. We're approaching these towering dark pillars. They look solid, but they're composed of microscopic dust grains, smaller than smoke particles, less than 400 thousandths of an inch across. Yet, over trillions of miles, they accumulate enough to block out starlight completely. These aren't just shadows. They are cold, dense molecular clouds, where gravity is winning the battle, clumping gas together to eventually ignite nuclear fusion and birth new stars. This structure is reminiscent of the famous pillars of creation. See those tiny bumps on the surface? Astronomers call them EGGs, evaporating gaseous globules. They look small, but a single one is roughly the size of our entire solar system. About 9 billion miles, 14.5 billion kilometers across. We are witnessing photoevaporation in action. Intense UV light boils away the outer layers, leaving behind these dense pockets that act as shields, protecting the embryonic stars forming deep inside. As we pull back, the colorful nursery recedes, and the cold reality of the cosmos returns. We are crossing the boundary into the interstellar medium. The density drops precipitously here, leaving the nebula. The average distance between stars jumps to approximately 5 light-years. That's roughly 30 trillion miles, 48 trillion kilometers of empty, lonely void. The vibrant energy of birth is left behind, replaced by the vast silence of the galaxy. And finally, the grand context reveals itself. That massive nebula was just a tiny speck within this. A majestic spiral galaxy spanning 100,000 light-years, or 600 quadrillion miles, 965 quadrillion kilometers in diameter. It holds an estimated 400 billion stars. The structure tells the story of time itself. The bright yellow core is a city of ancient cooling stars, while those blue spiral arms are density waves, triggering the formation of hot young stars and nebulae, exactly like the one we just explored.